Hi everybody. So we're just going to go over a selection of questions aimed at GCSE students regarding equations of lines, parallel and perpendicular lines, midpoints and gradients, similar topics. Okay, so we're going to start off with a few questions here, which I recommend you start off working on topics like this. Algebra as well is quite important, so just solving linear equations and this stuff here, which is rearranging, okay, and making different things a subject of the formulas, because we're going to be doing a lot of this in the questions that follow. So I'm going to start off just with a couple of questions like this. So first question, make S the subject of the following formula. So my general rule is I'm going to see which term contains an S in it, and it's this one here. I'm going to move every other term to the other side of the equal sign, and then I'm going to deal with the things that are attached to the S, okay? So the first thing I'm going to do is I'm going to notice that U squared is the only term that doesn't contain an S in the right hand side, so I'm going to subtract it from both sides of the equation, okay? So I get V squared minus U squared equals to 2AS, and then I can observe that the 2A is stuck to the S with the times sign, okay? It's being multiplied together, and the opposite of timesing by 2A is dividing by 2A. Okay, so I'm going to divide both sides by 2A, and you should see that S equals to V squared minus U squared over 2A. Okay, that's the first one done. Second one here, make N the subject of the formula. So again, I'm going to observe N is in this term here, and the 21 has no N in it, so I'm going to move it over to the other side. I'm going to add 21 on both sides. So we'll get M plus 21 is equal to 5N. And then what I'm going to do is I'm going to divide both sides by 5. Okay, so I should get M equals to M plus 21 divided by 5. Okay, next one, make T the subject of the formula. First thing I'm going to do is I'm going to subtract U on both sides. So I get V minus U. It's important when you have questions with V and U that you distinguish them from one another, because it can be very confusing. So I get V minus U is equal to 5t. What I'm going to do now is I'm going to divide by 5. I'm going to divide both sides by 5. See the 5 cancels, and I get t is equal to V minus U, which I haven't distinguished properly, over 5. Yeah, t is V minus U over 5. Perfect. Next one here, make U the subject of the formula. So I'm going to, again, it's a bit more of a complicated question, but same principle. I have this term here that's got a U in it. This hasn't, so I'm going to move this term to the other side by subtracting it. Okay, so I subtract kt squared on both sides. Okay, I'm just doing the kind of the full working out for this question, because it's a little bit more complicated. It can be a bit tricky when you see something squared, but I recommend to do all those steps in every question. I'll just skip them out purely to save time. So you should get on the left hand side d minus kt squared is equal to ut, and now what you can do is divide both sides by t, because we know in maths when there's a letter next to another letter, or a number next to another letter, it means times. Okay, so in order to remove that t, we're going to have to divide through by t. So you should find that u is equal to d minus kt squared all over t. Okay, last one here, and I'll scroll down a little bit. X equals to 3y plus 2. So first thing I can do is I can subtract 2 on both sides. Okay, so I'm just going to minus 2, I'll just do the working out because I've got a bit more space here. X minus 2 equals to 3y, and now I'm going to divide both sides by 3, and you should find that you get y equals to x minus 2 over 3. Okay, so just for the purposes of the questions that are going to follow, what I'm going to explain to you now is that you can further simplify this, and you can separate the two terms at the top, because you know that the x and the 2 have the same denominator. Okay, so this is exactly the same as writing x over 3 minus 2 over 3, right? And what I tell my students is, you're used to going this way, but it's a bit counterintuitive to go this way. Like if you have two fractions that have the same denominator, you're used to putting them over the same denominator and then, doing some arithmetic at the top, subtracting or adding, whatever. This should go the other way. Okay, so I can observe that both terms share the same denominator, so I'm going to separate it out. Okay, and not to confuse anybody, this is exactly the same as a third x. X over 3 is exactly the same as a third x minus a 2 over 3. Okay, so I've just written it in a kind of different way, and it's important that you understand that we can do this, because this will allow us to determine the gradient and the y-intercept of our lines. Okay, so we've just got a couple of points here which I feel to be important for this topic. So obviously we know the equation of the line, y equals mx plus c, and m is the number in front of the x. And just remember that if it's positive or negative, and that's the gradient, and c is the number with no x on it. Okay, and just again remember the sign in front of it. Is it positive? Is it negative? And that's where the line crosses the y-axis. Okay. The very important part of this topic is you must, whenever you have an equation of a line, you must rearrange it to this form first before you read off the gradient and the y-intercept. Okay, so if you have an equation of a line that's been given in this form, 2x plus y equals to 3, you cannot simply say, oh, the number in front of the x is the gradient, therefore the gradient is 2. That's not correct for a question like this. Okay, you're going to have to rearrange and get y by itself here, and then read off the y-intercept and the gradient. Okay, so just think about midpoints here. We've got the equation for a midpoint between two coordinates. So it's just simply the average of the x-coordinates and the average of the y-coordinates. Okay, so you add the x-coordinates together, divide by 2, add the y-coordinates together, divide by 2. It's just as simple as that. Here we have the gradient between two points or two coordinates. So you're going to be finding, instead of now the sum of the x-coordinates and then divide by 2, you're going to be finding the difference, okay? So this is going to be the difference of the y-coordinates, and we're going to be dividing it by the difference in the x-coordinates, okay? Some people will write this as... some people will write this as delta y over delta x, so you may see it like that as well. So this just means change in y over change in x, okay? And it's important that you do this in the same order, okay? y2 minus y1 over x2 minus x1. Or you can do, this is identical to y1 minus y2 over x1 minus x2. It's exactly the same. As long as you do it in the same order. The first y-coordinate, take away the second, over the first x-coordinate, take away the second. You would not be able to do the first y-coordinate, take away the second, divided by the second x-coordinate, take away the first. You can't do that. You do the first minus the second over the first minus the second, or the second minus the first over the second minus the first. Okay? Another important point here, parallel lines have exactly the same gradient, and I've just put it here, there's no easy way to remember this is easy. So just the way I think about it is gradient tells us the steepness of a line. So if you draw two lines that have the same steepness, they will be... So if you draw two lines, if you draw two lines with the same steepness, they're going to be parallel. Yeah, and if you draw two parallel lines, they're going to have the same steepness. They're going to have the same gradient. Okay. So if you know a gradient of a line is 3, and you know this line is parallel to it, then you know the gradient of this line is also 3. Okay, so they have the same steepness. And to find the gradient of a line that's perpendicular to another, you find the negative reciprocal of that gradient. Okay. So for example, if you have, we know, here's a line, let's say the gradient is 2, okay? Got another line here, and it's perpendicular now, okay? So we want to know the gradient of this line, it's the negative reciprocal, okay? So we're going to flip this and make it a negative, okay? So it's going to be minus a half. What a lot of people trip up on here is whether or not you have a fraction as a gradient, okay? So the thing I like to tell my students is if you have a just a whole number here, then you put 1 over it and then you make it negative. That is the negative reciprocal. However, if you have, let's say, a fraction, 3/4, that's the gradient of this line, and you want to find the gradient of a line that's perpendicular to it, you just flip that fraction and you put a negative in front of it, okay? So minus 4 over 3. Okay. You can also look at this actually as well as the gradient of this line is 2 over 1. 2 as a fraction is 2 over 1, and then flipping 2 over 1 is a half, and then obviously put the minus in front of it as well. Okay, so just quickly going over the key points you need to know. So let's just fill out this quickly. The gradient of a line describes the steepness, okay, and the y-intercept tells us where the line cuts the y-axis, okay, so it's where the line cuts the y-axis. Okay, so they're the two important things you need to know for a line. If I have a coordinate axis here, I've got my x coordinates, my y coordinates, I need to know where it crosses the y-axis, and I need to know how steep it is. So that's like the ratio between the rise over the run is what a lot of people call it. Okay, so they're the two most important things you need to know, y equals mx plus c. If the gradient of a line is 5, the gradient of the line that's parallel to it is going to be 5. Okay, so I'll just pause quickly after each of these so you can think about it yourself, and feel free to pause the video at any point to have a go at any of these things, and then you can watch me do the solution afterwards. If the gradient of a line is -7, the gradient of a line that's parallel to it is, well, it's going to be -7 as well, because they're exactly the same. If the gradient of a line is 3 or 4, the gradient of a line that's parallel to it is, it's going to be -3 or 4 as well. Excuse me, it's going to be +3 or 4, because that was +3 or 4, and this line is parallel, so they have the same gradient. And the gradient of the line that's perpendicular to it now I'm going to do the negative reciprocal, and I am going to flip it and put a negative in front of it, so it's -4/3. Okay, so what this is saying graphically, if I draw this, let's say we have a line and its gradient is 3 or 4, okay, which means if you pick a point, you have to go 4 jumps across and then 3 jumps up to get to the next point on the line, okay? So that's the gradient of that line. If we want to find a line that's perpendicular to it, I probably forgot to mention actually, perpendicular means they meet at right angles, okay? So that's quite important. Probably should have mentioned that before. So if we want to find a perpendicular line to it, i.e. a line that meets this line at a right angle, we know the gradient of it straight away. It's -4/3. Yeah, just a negative reciprocal. But this stuff will become a bit more easy once we have a go at a few questions, okay? So find the gradients of the y-intercept of each of these lines. Okay, so let's go through some of these. X plus y equals 10. So as I mentioned before, we have to rearrange this in the form y equals mx plus c. So I'm just going to write it up here, y equals mx plus c. We have to get all of these lines in the form y equals mx plus c before we can read off the gradients and the y-intercepts, okay? So for the first one, I'm just going to subtract x from both sides. So you should see that y equals to -x plus 10. So we know the gradient is the, I'll just write this a bit better because it's not very good handwriting. So we know the gradient is the number in front of the x, remember? What number's in front of the x? Well, it's just -1, okay? So the gradient is -1, and the y-intercept is 10 for this one. That's done. For the second one now, so what we can do at this point now is because the y is negative, one common mistake that I know a lot of students make is they leave the y negative and they have -y equals to -x plus 4. That's completely fine, but what you have to do at this stage, because there's a -1 stuck to the y, you need to divide everything by -1, okay? So y is actually equal to x minus 4, okay? And you'd get exactly the same thing if you plus y on both sides and then subtracted 4 on both sides. Okay, so we can see that the gradient is a number in front of the x, and there's no number, so it's just 1. Because there's 1x there is another way you can think of that. There's only 1x, so it's just 1, and the y-intercept is -4 for this one, okay? It's done. This one here, I'm going to leave y as it is, and subtract 2x on both sides. So I get y equals to -2x, because I subtracted it, plus 6, okay? So the gradient is -2, and the y-intercept is 6. Next one here, again, I see that there's a negative y, so I either take the 3x over and then divide by -1, or probably a bit easier, I'm going to add y on both sides. I'll just do it over here. So I'm just going to add y on both sides, so I get 3x equals to y minus 1, and then I'm going to add 1 on both sides as well to remove this -1. Okay, so I get 3x plus 1 equals to y, and you should see that the gradient is 3 and the y-intercept is 1. So that's that one done. Next one here, a bit more tricky, is a few more terms. So I'm going to keep the y as it is, and I'm going to move the 8x, and I'm going to move the 9 over. Okay, so I'm going to subtract 8x on both sides, and you should see that you get 2y plus 9 equals to -8x. Okay. Then what you can do is you can subtract 9 on both sides as well. So let me just move him there. And I'm going to subtract 9 on both sides, so it should read -9. Okay, what you can do at this point now is divide both sides of the equation by 2. So that'll get rid of the 2 from there, and divide this side by 2 as well. So I'm just running out a bit of space, but I'll just put it there. Okay, so we can simplify this. Let's simplify it, and let's separate these two terms here. Okay, so let's just put it down here and I can write it out afterwards. So I have y equals to minus 8x minus 9 over 2. Okay, and I know both these terms share the same denominator. So I can write this as minus 8x over 2 minus 9 over 2. Okay, and I know that minus 8 over 2 is simply 4. Okay, so I can just have this as, excuse me, minus 4. Minus 8 divided by 2 is minus 4. So this is going to be minus 4x should be down here. Minus 4x minus 9 over 2. So gradient is minus 4, and the y-intercept is minus 9 over 2. It's completely fine for you to leave your answers as a fraction. Okay, let's have a go at the next one. Keep this space a bit less cluttered. This one here. So I observe again that the y term is negative. So I'm going to add 2y on both sides. So I get 5x minus 4 equals to 2y. I hope you see a pattern emerging here. Depending on whether or not the y is positive or negative, you're going to have to either move the y or move the other terms to get the y by itself, okay? Now at this point, I can just divide both sides by 2. So I'm going to divide both sides by 2, divide by 2, and I can then separate this. Okay, so I know that this is exactly the same as 5x over 2, 5x over 2, minus 4 over 2, which is 2. Okay, so I know that y is equal to, so I'll just write it over here just to finish it off. So y is equal to 5x over 2 minus 2. Okay, so I can just observe that the gradient now is the number in front of the x, and this is 5 over 2, or 2.5, and the y-intercept is minus 2. Okay, so we're done there. So yeah, there is a bit of a pattern that emerges in these questions. So we've done that. So I'm not going to attempt every question because just for the sake of time. So I hope you gain something from that. Let's have a move on to question 11. I will mention in the description where I got these worksheets from, so you can go and download them. Most of them are just from Math Genie and Corbett Maths. So you can download them, and they have work solutions as well, so you can work through them in your own time. Just a little note on this question here, I would probably fix any mixed numbers and I would put them into improper fractions first. That may help at this stage, but it's going to be the same process. So find the coordinates where the following lines cross the x-axis. Okay, so just a little bit of an explanation now. Where do lines cross the x-axis? Where do lines cross the y-axis? Okay, so the way I like to teach it, although if you have an equation of a line in the form y equals mx plus c, you can simply state that c is where the graph crosses the y-axis. It's the y-intercept, okay? But more generally speaking, if you have a line here, the line will cross, I'll just mark on the y-axis and x-axis as well. So the line will cross the y-axis when its x-coordinate is 0. If you notice, here's my pointer. My pointer is here, and what I usually do is I ask my students at this point, how far across is my, well, we can do it here. I can say, how far across is my pointer here? And they'll say, oh, it's about, I don't know, 2 units across. And then 5 units up, that's the coordinate over there. And you get smaller and smaller and smaller until you reach here. And then you ask them, how far is my pointer across? Well, it's 0 across. It's not any distance to the right, or it's any distance to the left. It's 0, so its x-coordinate is 0. Okay, so to find where a graph crosses the y-axis, you make x equal to 0. Okay, which is why you can just read it off here, because when x becomes 0, this term goes away, and you're just left with y equals to c. Okay, so now to find where the graph crosses the x-axis, it's the opposite. Okay, so you're going to think, what is my y-coordinate at this point here where the graph crosses the x-axis? Well, how far up or down is my cursor at this point? Well, again, using the same logic as before, my cursor is 0 units up or down. Yeah, it's not any distance up or down. So to find where a graph crosses the x-axis, you just make y equals to 0. Okay, so that's a very important point. I'd recommend everybody make a note of that. So to find the y-intercept, you make x equal to 0. To find the to find the y-intercept, you make x equal to 0, and to find the x-intercept, you make y equal to 0. Okay, so what we're going to do in all of these questions here, asking us to find the x-axis, where the line crosses the x-axis, is to make y equal to 0 and solve the equation. Okay, so I'll do the first one as an example. Y equals to 2x plus 6. So all I'm going to do is make y equal to 0 in this equation. So I'm literally going to write out the equation exactly how it is, but replace y with 0. Okay, so I get 0 equals to 2x plus 6. And I'm going to subtract 6 on both sides. Minus 6 equals to 2x. And I'm going to divide both sides by 2. So I get x equals to minus 3. Okay, so I know this graph crosses the axis, the x-axis at the point minus 3, 0. Okay, so I'm just going to go through a couple of them. I'm not going to go through all of them. Like I said, I'm going to mention in the description below, I'll link where I got these worksheets from, so you can attempt them in your own time as well. Let's have a look at this one here, question I. Y equals a half x plus 3. So as again, exactly the same process. Make y equal to 0. So 0 equals to a half x plus 3. Now I can subtract 3 on both sides, so I get a half x equals to minus 3. And now I need to think about how to remove a half. Okay, so a half x is the same as x over 2, and that's equal to minus 3. So now the x is being divided by 2. The opposite of dividing by 2 is timesing by 2. That's the inverse. Times by 2 on both sides, times by 2 divided by 2 cancels out. So I'm left with x equals to minus 6. Okay, so I know the coordinates of where this graph crosses the x-axis is minus 6, 0. Okay, so I'll leave that for there because these questions aren't too difficult, but as I mentioned before, I'll link the worksheets in the description so you can have a go in your own time. Okay, so now we come to finding the equation of a straight line that passes through pairs of points. Okay, so as I mentioned before, we've just got a formula to work this out. M equals to y2 minus y1 over x2 minus x1. Okay, so if I confuse you in my explanation before about it's okay if you could do it the other way around, then you can just leave it as this and you can just use this formula. Okay, there's no problem with just using this formula. So first thing I'd recommend to everybody, once you're getting used to these questions, just label the coordinates x1, y1, x2, y2, and simply just substitute them into the formula. So I'll do this first one here, y2 minus y1, so it's 11 minus 5 over x2 minus x1, which is 4 minus 2. Okay, 11 minus 5 is 6. 4 minus 2 is 2. 6 divided by 2 is 3. So I have the gradient between these 2 points is 3. Okay, so I'll just jump to a couple of different ones with negatives now. So again, the same process. So I list out my coordinates, x1, y1, x2, y2. And when you get quicker at this, you could just read them off. So you could just do in your head 4 minus minus 5 minus 7 minus minus 10. But I'd recommend when you're starting off just to use the formula. So we have y2 minus y1. So it's 4 minus minus 5. Be very careful with the negatives here because we're subtracting these two numbers from one another. Okay, and this one already has a negative in front of it. So it's 4 take away minus 5 over minus 7 take away minus 10. Okay, so 4 minus minus 5 is the same as 4 plus 5, which is 9, over minus 7 minus minus 10, which is the same as minus 7 plus 10, and that's 3. 9 over 3 is 3. Okay, so one thing you need to be careful in questions like this is to really make sure you're using your brackets and you're being aware of the negative signs. So questions like this will be an absolute nightmare. In fact, we might, let's just try this one now to finish off this section. So again, labeling our coordinates, x1, y1, x2, y2. What I'm doing is tedious, but you will make mistakes less frequently. Okay, so y2 take away y1, so it's 2 minus minus 4, divided by minus 3 minus minus 6. So just write it all out. I'd really recommend to write it all out. Minus 3 minus minus 6. Okay. and I will probably most likely make a few mistakes in this video, so if you spot a mistake, just let me know in the comments below, because I'm a nightmare for getting negatives as well. -2, sorry, so it's 2 minus -4 over -3 and minus -6. I'm making myself paranoid now. So 2 minus -4 is 2 plus 4, which is 6. -3 minus -6 is the same as -3 plus 6, and -3 plus 6 is 3. 6 divided by 3 is 2. So we see the gradient of the line joining these 2 points is 2. Okay, so I'll leave the rest of them. You can have a go in your own time. Let's have a look at some of the next ones now. Okay, so we get into questions now that involve using equations of lines. Okay, so I'm going to write the equation, general equation of a line up here, y equals mx plus c. Okay, so now let's try it. A straight line has equation 2y minus 10x equals 8. Work out the gradient of this line. Okay, so the biggest mistake you can make at this point is just saying it's minus 10. Be very careful. It should be in the mark should be indicative of the amount of working out as well. If it was just as simple as reading it off and putting it in there, it would be a 1-mark question, but it's not. It's a 2-mark question, so there's a bit of working out. So as I said before, we're just going to be rearranging. So adding 10x on both sides, obviously because I should have wrote x. Adding 10x on both sides because we observe it's a minus 10x. So you should see that you get 2y equal to 8 plus 10x. Now dividing both sides by 2, I see that y is equal to, so what I'm going to do for the moment is you can write it out to 8 plus 10x over 2 and then separate them into 2 fractions, but I can just realize 8 divided by 2, 4. 10 divided by 2 is 5x. Okay, 4 plus 5x. So I'm not done yet. I can't just write this. I need to write the actual gradient, and that's the number in front of the x. Okay, whether it's positive or negative. So in this case, the gradient is positive 5. Okay, you will not lose marks for mentioning if it's positive or negative. Write down the equation of a line parallel to this line. Okay, so an equation of a line that's parallel. If this is this line here, I'll call this straight line here, I'll call it L1. Okay, this is L1. L2 is parallel. Okay, so what's the same between them? They have the same steepness. So L2 has a gradient of 5. So we know that m is equal to 5 straight away for this line. So we can just write out our equation now. So we can write out y equals to 5x plus, and we get stuck here and we think, what's the y-intercept? Well, it doesn't matter. The y-intercept can be a million it doesn't matter. It can be anything. Okay. So what they have in the mark scheme is y equals to 5x plus c, and the mark scheme will literally say c can be any number. Okay, if you think about that on the coordinate axis, so let's say we have y equals 4 plus 5x. So this line L1 is somewhere roughly here. Okay, and it's got a y-intercept of 4. Okay, I'll do another color now. I'll do a line parallel to it. Okay, and it crosses the y-axis here. But another one could be like way down here. It's still parallel, but it's got a different y-intercept. So the y-intercept does not matter for questions like this. Let's have a look at the next one. A straight line has equation 4y minus 5x equals 2. So again, similar process. I'm going to add 5x on both sides. So we get 4y equals to 2 plus 5x. Now divide both sides by 4. Y equals to 2 plus 5x over 4. That's equal to 2 over 4 plus 5x over 4. Okay, and I can simplify both parts of it. Y equals to 2 over 4, which is a half, plus, and I actually can't simplify the second part, so it's just 5 over 4. Okay, I would recommend keeping your answers in fractions instead of decimals. It just makes it easier to keep an eye on them. So the gradient of the line is the number in front of the x. It's going to be 5 over 4. Write down the equation of a line that's parallel to this line. So we saw as before, an equation, if they're asking you just for an equation parallel to another line, you have to have the same gradient, y equals 5 over 4x, and I can just say minus 10. Yeah, it can be whatever I want, positive or negative, okay? Very similar to this previous question up here, okay? Let's have a look at the next one now. Okay, so diagram shows, so I won't be able to fit it all in, but we'll make the most of it. So we've been asked, diagram shows 4 straight lines, they've all got labels, and we need to match each label to the equation, okay? So first of all, I'm going to see that 3 of them are kind of normal looking, if you want to call this a normal line, and one of them is a bit strange. It's flat, okay? So let's try and work out what's the equation of Q. Which one looks like the equation of Q? So I'll pause for a second. You can have a think about it. Maybe think about the gradient of Q. How steep is this line? Well, in actual fact, the gradient of this line is 0. It's got no steepness, okay? So if we write out the equation of a line, y equals mx plus c, and if m is 0, the gradient is 0, this term is just going to be completely gone. So we're just going to be left with y equals c. Y equals a number, okay? And that matches with d, okay? So we know that q matches with d. I'll just write them here. There's just not enough space to go up and down. So this is q here, okay? Or it might be easier. I'll just put d up here. Okay, and we can see that this y coordinate, we'll say, is 3. We can observe as well that every point on this line has a y coordinate of 3. Therefore, this is the line of y equals to 3. Okay. Let's have a look at another interesting. Okay, let's take this one here. Let's take line S. Okay. Let's have a look. Let's think about the gradient of the y-intercept. Well, we can't really tell much about the gradient other than the fact that it's positive. And the y-intercept is 0. Okay, so let's think about an equation of a line. Y equals to mx plus c. If the y-intercept is 0, that means this c term is 0. So we just have y equals mx. So it's a line in the form y equals to mx, and that corresponds to a here. Okay, so y equals to 2x. So this line here is a. Okay, because there's no y-intercept. It crosses the y-axis at 0. Okay. Equally, we could just write this 2x plus 0 like that and observe that there's no y-intercept. Okay, so one small point that I wanted to get to now. So we have 2 left. We have y equals 2x plus 3 and y equals 3 minus 2x. So I'll just write them up here. So we've got one of them is y equals 2x plus 3 and one of them is y equals to 3 minus 2x. A bit easier. Okay, so we notice these are basically the same thing. But one of them has 2x, one of them has minus 2x, okay? It might be easier for you to see it if I wrote this one, but I'm just going to write it as y equals to minus 2x plus 3, okay? So okay to swap things around, it's completely fine. So let me just erase this one out here. Okay, so I've got, excuse me for that. So I've got y equals 2x plus 3, y equals minus 2x plus 3. Okay, so what I want to point out here is gradients, negative and positive gradients, okay? So gradients, so lines that go from the bottom left to the top right of the graphs have a positive gradient, okay? So we can see that R is y equals 2x plus 3 because the gradient is positive, okay? So we know this is y equals 2x plus 3, okay? And we know that lines that go from the top left to the bottom right have negative gradients, okay? So we know that this one is y equals minus 2x plus 3, okay? So an important thing to note, I probably should have mentioned it at the start as well actually, that lines that go from the bottom left to the top right, or anything like this, anything that's going from kind of left to right and it's going up, all of these have positive gradients, okay? And then in the other direction, lines like this have negative gradients, okay? So let's move on to the next one. Work out the equation of a line that is parallel to the line y equals 5x minus 3 and passes through the point minus 2 minus 4. Okay, so it's parallel to this line. What's the gradient of this line? Well, the gradient is 5. So we know the gradient of our line must also be 5 because parallel lines have exactly the same gradient. And it must pass through this point. Okay, so let's think about the equation of a line. Y equals mx plus c. And we know straight away that m is 5. We know the gradient is the same as the line they gave us. So this is y equals 5x plus c. And let's think about what they gave us here. We have a coordinates. We have a coordinate. We know we have an x coordinate. We know we have a y coordinate. And we conveniently have a place for x and y. So why don't we just plot them in? So we know y equals minus 4 equals 5 times minus 2 plus c. Okay, so what they're doing here is they're giving us this information so that we can find c. Okay, because now we have one equation, one unknown, we can solve it. Okay, minus 5 times, it's minus 2 times 5 is minus 10, so minus 4 equals to minus 10 plus c. Adding 10 on both sides, I see that c is equal to 6. And therefore the equation of the line they want is y equals to 5x plus 6. Fantastic. Next one, line has equation y equals 2x plus 6. The line that crosses the x-axis, the line crosses the x-axis at point A, crosses the y-axis at point B, and point C has coordinates 1, 8. Find the coordinates of point A. Okay, so let's do part A. Part A is asking for the coordinates of point A. Point A is where the line crosses the x-axis. Lines cross the x-axis when y equals to 0, just like in the explanation I gave before. So if you are not familiar with that, rewind back the video and have a look. So y equals to 0. So I'm going to write out this equation again, and I'm just going to replace y with 0. That's all I'm going to do. 0 equals to 2x plus 6. And now I've got one equation, one unknown I can solve. 2x equals to minus 6 by subtracting 6 on both sides. Now by dividing both sides by 2, x equals to minus 3. So I know that the coordinates of point A, the x-coordinate is minus 3 and the y-coordinate is 0. So it wanted it in coordinate form, so I'm going to write it minus 3, 0. Okay, let's have a look at part B now. Find the coordinates of point B. Point B is where it crosses the y-axis. So y equals to 2x plus 6. Two ways you can do this. You can either just quickly observe that this is the y-intercept only because the equation is in the form y equals mx plus c. Y is by itself. So I know that the y-coordinate is 0 and the x-coordinate, excuse me, that's not correct. So I know that the y-coordinate is 6 and the x-coordinate is 0. Okay, when a line crosses the y-axis, its x-coordinate is 0. Okay, you could also use that information to substitute x equals to 0 in this, and you'll get y equals to 2 times by 0 plus 6, which of course just gives us y equals to 6. Okay, but it's important to know when the line crosses the y-axis, its x-coordinate is 0. Find the equation of the straight line passing through points A and C. I'll just scroll down for a little more space. Okay, so point A and point C. Well, point A is minus 3, 0, and point C is what they gave us in the question, 1, 8. Okay, so here we have our first question where they've given us two coordinates and we need to find the equation of the line passing through these coordinates. So two things we need to know. When we find the equation of a line, we need to know M, we need to know C. Okay, so let's first find M. Okay, let's find the gradient. So labeling both x1, y1, x2, y2. We know the formula for our gradients is y2 minus y1, which is 8 minus 0, over x2 minus x1, which is 1 minus minus 3. Okay, and 1 minus minus 3 is the same as 1 plus 3. 8 minus 0, 8. 1 plus 3, 4. 8 divided by 4 is 2. So I see that the gradient of this line is 2. So I know this line looks something like this. Y equals to 2x plus c. Okay, now how do I find c? So we're in the same situation again as we were in the question up here. Okay, we have an equation, we don't know c, but we know a line we know a point that this line passes through. We can use either one of these things, okay, because it passes through both of these. So let's just use c. Okay, we know the x-coordinate is 1 and the y-coordinate is 8, so I can substitute y is 8 and x as 1 into my equation, and that will help me find c. 2 times 1 is 2, minusing 2 on both sides, I see that c is equal to 6. So now I'm done. I can put it back into this equation here, and I get y equals to 2x plus 6. I'm done. Okay, another one here. Straight line has equation y equals to 5 minus 3x. Write down the gradient of this line. Okay, so what I'm going to do is I'm going to make it slightly easier, and I'm going to write this as y equals to minus 3x plus 5, which is exactly the same. I'm just swapping the order of the terms, and I can read straight off that the gradient is minus 3. Only, again, because it's in the form y equals mx plus c. Write down the coordinates of the point where the line crosses the y-axis. Again, we know when x equals to 0, So this term just goes away. It's just this number here. It's just 5. Okay, nice easy question there. So getting a bit repetitive, so let's skip a few of them just to save time. Don't want this video to be too long. Okay, let's have a look at this one here. The line crosses the y-axis at P. Right, what is the value of y at P? Okay, so it's asking for this point here. So this is just a y-intercept. So I know it's just this number here. And I think this is exactly the same question as the one before, but we'll continue anyway. Write down, okay, slightly different. Write down the equation of another line which is parallel to y equals 3x plus 5. Well, I know this line has to be in the form y equals mx plus c, and it has to have a gradient of 3. But the only thing is the y-intercept can be any number. So I'm just going to put y equals to 3x. I'll put pi. Y equals 3x plus pi. Pi is a number. I'll put y equals to 3x plus pi. Spice it up a bit. But I just want to stress this can be anything. Any real number. Okay, so let's have a look at this. A line passes through the point 0, 4. The gradient of this line is 2. Write down the equation of this line. Okay, so I know the line has to be in the form y equals mx plus c. I know the gradient is 2, so I can straight away, in fact, I can just delete that. And I can, scroll down here. So I can just, being annoying. So I can replace m with 2, excuse me. So gradient is 2, so I can replace m with 2. Now, how do I find c? Well, I realise they've given us an x-coordinate and a y-coordinate, so I can just sub them in. So y is 4, and x is 2 plus c. So again, they've given us this information solely to find the y-intercept. So 2 times 0 is 0, and you see that c equals to 4. So the full equation of the line is y equals to 2x plus 4. Okay, so what I did there is I just substituted this back in here. Okay, just to stress as well, it does bamboozle people sometimes. They're like, oh, but I haven't found y or x. It's okay, y or x don't need to be found. Y and x can be any coordinates along that line. Okay, so y and x, there's an infinite amount of y's and x's. So whenever you have an equation of a line, you never need to find y or x to display that equation. Okay, let's have a look at some of the extensions. A bit of a trickier question here. So they've given us the question in reverse now. They've given us coordinates, and we don't know one of the coordinates, and they've told us a gradient, and we need to work out the value for k. So I can use the equation, horrible handwriting, m equals to y2 minus y1 over x2 minus x1. Okay, so I'm going to substitute everything I know into this equation now. So I know that m is 5, and that's equal to y2 minus y1. So I'm going to quickly label my coordinates, x1, y1, x2, y2. Okay, so y2 minus y1 is k minus minus 1. K minus minus 1 over x2 minus x1, which is 6 minus 2. Okay, so I'll just write it up here. Continue the working up here. Usually you should work down in maths, so try not to be like me. So 5 equals to, now k minus minus 1 is k plus 1. Divided by 6 minus 2, which is 4. Okay, now I can times both sides by 4. Cancels out. 4 times 5 is 20. 20 equals to k plus 1. Subtracting 1 on both sides, you should see that k is equal to 19. Okay, so if you cross this out and you write 19 here, now you can practice in your own time. Find the gradient now between these 2 points, 2 minus 1 and 6, 19. You should find out that that value will turn out to be 5. Okay, let's have a look at the next one here. Okay, same thing but slightly harder. So I'm just going to, I'll scroll up here and I'll just use the same equation. M equals to y2 minus y1 over x2 minus x1. So I'm going to label in my coordinates x1, y1, x2, y2. Okay, so I'm going to substitute them straight in. So I know the gradient of this line is 4, so I know 4 equals to y2 minus y1, which is 12 minus 4, over x2 minus x1, which is k minus minus 3. Okay, be very careful with those negatives. Okay. At this point I've got everything I need, so I can just scroll down. So do it over here. 4 equals to 12 minus 4 is 8 over k minus 3, which is k plus 3. Okay, so this is the point where people get quite confused. They don't know what to do. Just treat this like a number. Okay, we have a fraction. We want to get rid of the fraction, so we're going to times through by the denominator. Okay, the 8 is being divided by k plus 3. So in order to remove it, we're going to times both sides by k plus 3. Times by k plus 3. Okay, so timesing by k plus 3 and dividing by k plus 3, they cancel each other out. They have opposite effect on one another. So I'm just left with 4 times by k plus 3 is equal to 8. Okay. So I need to remember that the 4 is being times by everything in this bracket. So the 4 needs to be times by the k, and the 4 needs to also be times by the 3. Okay, so I'm going to expand it out. 4k plus 12 equals to 8. Okay, now I can subtract 12 on both sides, and I get that 4k equals to minus 4. Now dividing both sides by 4, I should see that k equals to minus 1. So I'm done. And again, like I said before, you can cross this out, you can write minus 1 in place of it, and now calculate the gradient between these 2 points. You will find that you will get 4. It's a good way to check your answer. Okay, show that this line is perpendicular to this line. Okay, first of all, 2 lines that are perpendicular. I know the gradient of one will be the negative reciprocal of the other. Okay, so what I'm going to do is I'm going to find the gradient of both of them first. Okay, so again, I have to divide by 3 because I have to get it in the form y equals mx plus c. So y equals to 4x minus 14 divided by 3. And now I can separate both terms. So this is the same as 4x over 3 minus 14 over 3, okay? And don't forget, this 4x over 3 is exactly the same as 4 over 3x, okay? It's just the 4 over 3 is in front of the x, okay? So I can see that the gradient of this line is just a number in front of the x, which again is just 4 over 3, okay? So let's think about, before we even calculate this one, what is the negative reciprocal of 4 over 3, okay? Well, you just flip it and put a negative in front of it, okay? So we should see 4 over 3 flipped is 3 over 4, and you should put a negative in front of it. Okay, so we should see that this line is perpendicular, so the gradient should turn out to be minus 3/4. Okay, so let's check. Okay, divide both sides by 4, so we get y equals to minus 3x plus 48 divided by 4, and again splitting this up because both terms in the top share the same denominator. Minus 3x over 4 plus 48 over 4. Okay, and we're done, because we see that this line has a gradient of minus 3 over 4. So we can write a little statement here, and I'd recommend you to write a little statement. I'm not going to do it just to save time. But we can say, since one line has a gradient that is a negative reciprocal of the other, we can conclude that they're both perpendicular. Okay, let's have a look at the next one here. The graph shows depth d of water in a tank after t seconds. Find the gradient of this graph. Okay, so to find the gradient of a graph like this, it can be a bit arbitrary sometimes. It can be a bit tricky, sorry. What I do is I pick 2 points on the line and just find the difference in the x, difference in the y, and divide them, exactly like we normally do. Okay, but I wouldn't pick a point here because it's very difficult to see what point this is. So I'd recommend you pick a nice point, is what I say to my students. This is quite nice because it corresponds to 20 and 180. And what's another nice point? This is a nice point. Oh, well, this is a nicer point. This is a nice point. Why is this nicer? Because this point, I would have had to have gone halfway between 120 and 60, and that requires effort. And I'm doing an hour video, so I don't have much of that anymore. So let me just, obviously you do this with a ruler in the exam, so you find the x and y coordinates of each of your points. Okay, so I see the difference in the x coordinates, which is going to be this line here, and then the difference in the y coordinates. Okay, 180 minus 60, and that is going to be 120. And here we have 100 minus 20, which is just 80. Okay. So now I can just do gradient m. I'll just write it over here just so you can see it properly because it's a bit strange writing it there. M equals change in y over change in x. Just remember, triangle means change. You may see it written like this as well, dy by dx. I think this notation is far better because you use this at A level, but triangle or d just means it's a small change. It's going to be 120 divided by 80. Okay, and we need to remember, is this positive or negative? Well, it's going from the bottom right to the top left, so it's going to be negative. Okay. Alternatively, probably maybe even a better way to do it actually is just label the coordinates of each point. So this is 20, 180, and this point here is 160. Okay, and just labeling them x1, y1, x2, y2, and just using the formula. Okay, so you'll see that m equals to y2 minus y1, which is 60 minus 180, over 100 minus 20. In fact, this is a much better way of doing it because it avoids having to decide whether it's positive or negative at the end. It just tells you 100 minus 20. Okay, and I see that this is going to produce the negative here. Okay, so m is equal to 120 over 80, which is 12 over 8, which is 6 over 4, which is 3 over 2. So it's minus 3 over 2. Okay. So yes, in hindsight, don't do what I did. I just rely on experience because I just remember it's probably best to label both coordinates and just use a formula because the formula will tell you if it's negative or positive. The formula knows, don't worry. It does the work for you. Explain what the gradient represents of this graph. Okay, let's have a think about it now. So we're dividing this quantity here by this quantity here. Okay. So the gradient is going to tell us the depth per second. Okay, so it's going to be the depth in water per second. Okay, you can think about this as you're dividing this quantity, which has a units of d, and you're dividing this quantity, which has a units of t. So when you divide two numbers, you also divide the units. So this is going to be depth. So I shouldn't have said units. This has units of centimeters, and this has units of seconds. So when you divide two numbers, you're also dividing their units. Okay, so it's going to be centimeters divided by seconds, and this shows us this will be the decrease in depth per second. Okay, so it's going to be the change in. Okay, so the general way to answer these questions is basically the change in blank. Horrible handwriting. The change in blank per unit blank. This blank is going to be whatever's on the y-axis. This blank is going to be whatever's on the x-axis. That's the far superior way to answer the question. Okay, so it's going to be the change in depth per unit time. Okay, that's the best way to answer this. The change in depth per unit time. And you can mention the change in depth in centimeters, so you can put centimeters here in brackets, per unit time in seconds. Okay. Let's have a look at some of these last ones now. So I just want to mention that these are high-level GCSE questions, the one we're in now. So, you know, I'd aim these students at year 10, year 11. So if you're not in those years, don't worry if you're not following along. ACB is a straight line, A is the 0.08 and B is the 0.40. C is the midpoint. Line DCE is perpendicular to line ACB. So essentially all the information here is just what's shown here. Work out the equation of line DCE. So we need to find the equation of this line here. Okay. Let's have a think now. We need to find the equation of this line. This line, well, lines have general equations in the form y equals mx plus c. Two things we need to know is m and c. Okay, can we find the gradient? It's going to be a bit hard because I don't know any points along this line. But can we calculate a point along this line? Yes, and the answer is yes. Okay. We've been told that C is the midpoint of AB, and we know the coordinates of A and we know the coordinates of B. The coordinates of B is 4, 0, and the coordinates of A is 0, 8. Excuse me. Okay. So I can find the midpoint of these two to find this point here, and then I can proceed from there. So the midpoint, you just add up the x coordinates, divide by 2. Useful if you label them as well. x1, y1, x2, y2. Okay. Add up the x coordinates. 4 plus 0 divided by 2 is 2. Add up the y coordinates. 8 plus 0 divided by 2 is 4. Okay, so straight away I know the coordinates of the midpoint. I know the coordinates of C is 2, 4. Okay. Let's have a think now. So I know one coordinate on this line. What else do I need to know? Well, I need to know the gradient. Let's have a think about the gradient. Okay, so how do I get the gradient? Well, I know this line is perpendicular to this line. So if I can find the gradient of line AB, it's really easy. Then I can just do the negative reciprocal of that number, and then I know the gradient of this line here. Okay, because they're perpendicular. Because we've been told that in the question. So let's try that here. Let's label the points. It's probably easier if I just label them up here. x1, y1, x2, y2. Okay, so let's find the gradient between them. y2 minus y1, so it's 0 minus 8 over 4 minus 0. Minus 8 over 4, which is just minus 2. Okay, so the gradient of this line is minus 2. The gradient of this line is going to be, well, what's 2 as a fraction? 2 is 2 over 1. Flip it, so it's going to be a half, and put a negative in front of it. So it's negative half, so it becomes positive. Okay, so it's just a half. Okay, so I put a negative in front of it, but there was already a negative in front of it, hence why it became positive. Okay, so fantastic. Now I know the gradient of this line is a half. That's great. And I know a point that lies on the line. Okay, so I can write out the equation y equals to half x plus c, and I'm nearly done. I know this is an x coordinate, this is a y coordinate, and they both lie on this line, so I can just substitute them in, exactly like we've been doing. Yeah, from this point it just becomes one of those previous questions where they give you the gradient and they give you a point on the line. Okay, so we have xy, so I can substitute y is 4 equals to half x, half times 2, plus c. Okay, half times 2 is 1, 4 equals 1 plus c. Subtract 1 on both sides, you get c equals 3. Okay, so I can finish off by just stating y equals half x plus 3, and we're done. This point here is just 3. Okay, so just to summarise, I found the midpoint of AB, because I've been told in the question it's the midpoint, and that gave me C. Then I find the gradient of line AB, and because I know it's perpendicular to the gradient of this line, I found the negative reciprocal of that number. Okay, so I found the negative reciprocal of minus 2, which was a half. That told me that the gradient of this line was a half. Then I know the gradient of this line, and I know a point that lies on the line. So I just use the same standard technique, plug them in, and I found C, and then I could write out the whole equation of the line. Okay. Okay, I've got a question here. Do those points lie in a straight line? Okay, have a think about it. I would probably sketch it actually. So I do a little sketch here. So I'll draw a couple points that lie on the same line. Terrible drawing, but I think you understand the point. Now I'll draw a couple points here that don't lie on the same straight line. What can I observe about this line? What can I observe about it? Well, I know that the gradient, so let's just label this A, B, C. I know that the gradient, they all share the same line, so they all must have the same steepness. So the gradient between A and B and the gradient between B and C should all be the same. Okay, so let's just check that. Let's check the gradient between, another way they could say this is collinear. I've heard this being described as collinear. Okay, so that's another way you could phrase this question. They could ask you if these points are collinear. Okay, so we're going to find the gradient of the line segment AB, the gradient of the line segment BC. If they're the same, it shows that they're all on the same line. Okay, so let's just check that. So m equals y2 minus y1, so 10 minus 4 over 4 minus 1. 6 over 3, which is 2. Same for BC. 20 minus 10 divided by 9 minus 4. Okay, 20 minus 10, 10. 9 minus 4, 5. 10 divided by 5 is 2. Fantastic. So I can conclude this has the same gradient as this, therefore they all lie on the same line. Okay. You could also find the gradient between A and C, and you could show that is 2 as well. Okay, that could further convince you. But what I've shown here, the gradient of AB is the same as the gradient of BC. It means if I take both the gradients are 2, so 1 step across, 2 steps up. And I've shown that this is also 2 as well, so 1 step across, 2 steps up. So you could draw on your steps as well if you want. You could show that they're the same. It's a nice intuitive way of thinking about it. Let's have a check here. The point 5 minus 2 lies on which lines below? Okay, let's think about this. I'll pause for a second and let people have a go, and you can pause, have a go, have a think about it. And one of my students said she never saw a question like this, which is absolutely true. You might never see a question in maths. Sometimes you could see a completely new question you've never seen before, so we're going to have to think about it a little bit. Let's think. This is a coordinate, we have an x coordinate, we have a y coordinate. We have a convenient place for x and y to go in every single equation. Let's plot them in and see if it works. Let's just plot y is minus 2 equals to x is 5 plus 7. So I get minus 2 equals to 12. Is that true? No, that's absolutely not true. So the way I kind of describe it is these coordinates do not fit in this line. Absolutely not true. They don't lie in the line because minus 2 is never equal to 12. Well, last time I checked, I don't know. It could be different now. Who knows? Okay. Alternatively, you could sub 1 in. So I could sub in y is minus 2 and show that x comes out different. Okay. So I'll try that for line B actually. I'll sub one of them in and see if I can get the other one to pop out. Okay, so let's sub in x as 5 into here. Okay, and we should see that the y coordinate should be minus 2. Let's check if that's the case. Y equals to minus 3 times by 5 plus 13. Minus 3 times by 5 is 15. Minus 15 plus 13 is minus 2. So I get y is minus 2. So when x is 5 on this line, y is minus 2. So this point must lie on this line. Absolutely correct. Okay, alternatively, you could have subbed y in and solved for x, but that would have been a bit more work. Okay, we could have subbed both in and showed that the equations make sense. You would have got something like 3 equals to 3, or 5 equals to 5, or 1 equals to 1. You would not have gotten minus 2 equals to 12. Let's try for the next one. Let's sub both of them in. Minus 2 equals to 4 times by 5, minus 18. Minus 2 equals to 4 times 5, which is 20. 20 minus 18 is 2. And minus 2 does not equal to 2. So we can conclude that the point does not lie in this line. Okay, let's do another one here. Let's just try subbing in a y coordinate. Okay, so y is minus 2 equal to minus 2 x minus 8. Okay, I wouldn't recommend to do this because it's going to be a bit more rearranging now and I'm more likely to make a mistake, but it's absolutely fine to do it. So I can add 8 on both sides. 6 equals to minus 2x. Divide both sides by minus 2. I get x equals to minus 3. Okay, but I should have got x equals to 5. Okay, because that's the point that corresponds to minus 2. So no, I can conclude that point D, that point does not lie on point D. Okay. Let's have a look at line F now. Line E, excuse me. Let's just sub them both in. Okay. So I get that minus 2 equals to 2 lots of 5 minus 12. Okay. Minus 2 equals to 10 minus 12, which is minus 2, and that works because minus 2 does in fact equal minus 2. Okay, so I see the only ones that work are B and E. Okay, let's have a look at the next one. I read the question. I'm just going to... Yes. Perfect, yes. Just checking the solutions. Okay, so let's have a pause of this if you want to have a go at it. Let's try this now. Straight line goes through these points. P, Q, R, S. Okay, so straight away, before we do anything, let's label them. X1, Y1, X2, Y2. Find the gradient of the line. How do we find the gradient of a line? Well, gradient of a line is equal to y2 minus y1 over x2 minus x1. Okay? Okay, that's good. What's y2 minus y1? Well, that's s minus q over x2 minus x1, which is r minus p. Fantastic. Okay, how do I get s minus q? Let's have a look at the equation that involves s and q. Let's think about it. Well, I could subtract q from this side. So I subtract q from this side and subtract q from this side as well. Q minus q is 0, so I'm left with 4 equals to s minus q. Fantastic, I know what s minus q is. It's 4. Do the same thing for this one. Subtracting p on both sides. So p plus 2 equals r. Subtract p minus p is 0. I'm left with 2 on the left-hand side equals to r minus p. So r minus p is just 2. Perfect. 4 minus 2 is 2. Okay, so a question like this, they want a numerical answer. If they're specific, if they're just asking for the gradient, it means they want a number. So just be aware of that, okay? If they ask for the gradient in terms of whatever letters, that's fine. But for questions where they just ask the gradient, it means they want a number as the answer, okay? So it's very easy to not get a number as the answer for this question. So just be aware of it, okay?
Okay, so for the next question, we've been told that A, B and C are the vertices of a right angle triangle, and angle ABC is the right angle, and we've been asked to find the equation of the line that passes through A and C, giving our answer in the form AY plus BX equal to C, where A, B and C are all integers. Okay, so I recommend a quick sketch. The sketch usually helps for questions like this. I find it very hard to visualize it in my head. Okay, so I'm going to find A. A is roughly 2 to the left, 1 up, so A is around here. B is 6 across, 5 up, so relative to A it's around here. 6, 5, and I'll just put it in, and that's B. A is minus 2, 1, so I'll just label that in there. And C is 4K, so it's 4 across and it's K upwards. Okay, assuming that K is positive, I'm going to make that assumption because we've been told that ABC is a right angle, so this point has to make a right angle. From A to B to C should be a right angle, okay? And like it could be this way as well. So let's say the two positions that C could be in is here, okay? Because if C is either here or here, we have a right angle here, and we have a right angle here. But as you can see here, the x-coordinate of C at this point is now bigger than 6, okay? So it's definitely not going to be down here, okay? But again, just the position of it doesn't really matter too much because this is just a quick sketch, okay? So I'm going to say this is my triangle here, A, B, C, okay? So what I've been asked to do is I've been asked to find the equation of this line here. This black line passes through A and C, okay? Okay, so what's really important in maths is that you strip away the information that you don't need and you find the information that you do need, okay? So they're asking us to find the equation of the line, fine. But what I like to tell a lot of my students is, like, what are they actually asking us? What do we need to find an equation of a line? What's the minimum amount of things we need to find the equation of a line? Well, just think about the equation of the line, y equals mx plus c. We need the gradient and we need the y-intercept. Okay, how do we get those things? We can get those things by literally having the gradient and the y-intercept. We don't have them for this question, so we can't just, it's not that easy. But we can get them from 2 points. Okay, we can so if we have two coordinates, let's say we have two sets of coordinates here. Okay, if we have two sets of coordinates, we can find the gradient between them, and we can find the y-intercept. Okay, so two coordinates is what you need to find the equation of a line. We have one coordinate, so the question is really asking, what is this coordinate here? It's 4k. So if we find k, the problem is complete because we have two coordinates and we can find the equation of the line. Okay, so that's what we're going to do first. We're going to find k. Okay, let's think about how we're going to find k. Okay, well I know k, I know point C is connected by a line to point B, and that is connected by a line to point A. And I know these two lines are perpendicular because they told us that in the question, okay? So I know this coordinate and I know this coordinate. So if I find the gradient of this line, I know what the gradient of this line will be. And then maybe I can use that to find k. Okay, so that's the approach we're kind of going to take. So let's consider AB, and let's find the gradient between AB. M equals y2 minus y1 over x2 minus x1. So let's do that now. 5 minus 1 over 6 minus 2. And that is 5 minus 1 is 4, 6 minus 2 is 6 plus 2, which is 8, and 4 over 8 is a half. Fantastic. So I know the gradient of this line is a half, and that makes sense because it's positive gradient and I got a positive number. If I got a negative number here, probably something going wrong, assuming that I've done my sketch correctly. Okay, so the gradient of this is a half, and I know this line here is perpendicular to it. Okay, so I can find the gradient of this line. It's the negative reciprocal of a half. Okay, so the gradient of this line is going to be flipping a half, which is 2 over 1, and then putting a negative sign in front of it. Okay, and 2 over 1, of course, is just minus 2. Okay, so I know the gradient now of this line highlighted in yellow is minus 2. Okay, so let's consider the line from C to B. Okay, let's consider the gradient. y2 minus y1 over x2 minus x1. And I know now what the gradient is. It is minus 2. So what I'm going to do is I'm going to rub out the m, and I'm just going to replace that with minus 2. Okay, and now what I can do, let me just rub out these and I'll just substitute them all in. Okay, so y2 minus y1 is 5 minus k, and x2 minus x1 is 6 minus 4. Okay, so I have 6 minus 4 in the denominator. Let's simplify that. So this is minus 2 equals to 5 minus k over 6 minus 4, which is 2. Multiply both sides by 2. We get minus 4 equals 5 minus k. What I'm going to do now is I'm going to add k on both sides. So I get k minus 4 equals 5, and now I'm going to add 4 on both sides. Okay, so I'm running out a bit of space here, but I'll just put it up here. I'll do it down here. So k is equal to 9. Okay, fantastic. So now I know what k is. K is equal to 9. So from the discussion we had earlier, I now have two coordinates that my line goes through. I can just find the equation of the line because that will give me the gradient, that will give me the y-intercept. Okay, so I can replace k now. Just rub out the k, and I know this is 9. Okay, so fantastic. So now it just whittles down to a basic kind of a question with two coordinates, 4, 9, minus 2, 1. Find the gradient between them. Okay, so find the line, the equation of the line between them. Okay, so to do that, we're going to find the gradient between them. So the gradient is y2 minus y1, so 1 minus 9 over minus 2 minus 4. 1 minus 9 is minus 8. Minus 2 minus 4 is minus 6. Negative divided by a negative is a positive. And I'm just going to simplify this fraction. 8 over 6 is 4 over 3. So this simplifies to 4 over 3. Fantastic. So I know the gradient of this black line is 4 over 3 now. So I can write this. I can use this equation I've got up here. So I know y equals to 4 over 3 x plus c. Fantastic. Now I can substitute a value of y and a value of x in to find c. Okay, and I can use either of these points. Doesn't matter which one. I'm going to use this one because it does not contain negatives, and it's going to make it easier. If any of them contain 0, I would use that one, because 0 would make a lot of it cancel out, and that's, we want to make it as easy as possible for ourselves. Okay, so what you can do now is you can sub in any point on this line, any pair of x and y would work. Okay, so I could use one miles and miles and miles all the way up here, and it will still give me the same value of c. Okay, but I'm just going to take this one here. So y is 9 equals 4 over 3 times by x, which is 4, plus c. So I see that 9 is equal to 4 times 4, 16 over 3 plus c. And now what I can do is I can start to rearrange. Okay, so I'm going to subtract 16 over, 16 over 3 is 8. So now I can just subtract 8 on both sides, and I see that c is equal to 1. And we're nearly done, so we can write it out. Y is equal to 4 over 3x plus 1, and they want it in the form ay plus bx equals to c. So what I can do now, generally, this is the general method to go from y equals mx plus c to this form. It's not that hard. You have two terms here, make them both into fractions, find a common denominator. So y is equal to 4x plus 3 over 3. As you can see, I've just timed this one, the top and the bottom of this one, by 3. So 1 over 1 is the same as 3 over 3. So I'll just write it out here. Actually, I probably should have done that in 2 steps. 4 over 3 plus 3 over 3. And then I know, because they share the same denominator, that's the same as 4x plus 3 over 3. Okay, so that's what I got there. And I'm just going to times both sides by 3. Times by 3, times by 3, times by 3, divide by 3, cancels out. We're left with 3y on the left equals to 4x plus 3. And now, just to get it into the form they want the 3 by itself, so I'm going to subtract 4x from both sides. Okay, let me just rub this out here just to get a bit more space. So I'm just going to subtract 4x on both sides. So I get minus 4x plus 3y is equal to 3. And now we are done. Okay, we can state the values of a, b, and c. A is minus 4 and b is 3. So we're done that question.
Look at this one now. Here are the equations of 4 straight lines. A, B, C, D. 2 are parallel. Write down the 2 parallel lines. Okay, so be very wary of the fact that a lot of them have a 2 in them, but only 2 of them are parallel. Okay, so the gradient of this, let's find the gradient of each one individually. The gradient of this line is 2. We can read off because it's in the form y equals mx plus c. To find the gradient of this line, we're going to have to divide both sides by 2. So we get y equals to x plus 4 over 2, which is equal to a half x plus 4 over 2, which is 2. So the gradient of this line is a half. So it's not this line. Do this one. I'm going to subtract 2x on both sides. So I get 2y equals to 4 minus 2x. Now divide both sides by 2. Y equals to 4 minus 2x all over 2, which is equal to 4 over 2 minus 2x over 2, because they have the same denominator, I can separate them. 4 over 2 is 2, minus 2 over 2 is minus 1, so it's just minus x or minus 1x, completely fine to write it like that. So I see that this line, it's a bit long now, so I'll just write it, y equals to 2 minus x. Gradient is the number in front of the x. What number is in front of the x? It's minus, what number is it? It's a 1, okay, so it's minus 1. The gradient of this line is minus 1. So it is not this one. Okay, so by process of elimination, I can say it's line A and line D. Absolutely don't do that in the exam. I would really recommend to find the equation, to rearrange. But just for the purpose of time and because I've checked it before, I know this is going to be correct. Okay, so you're going to add y on both sides. In fact, I'll just do it up here. Why not? It's not like the video is an hour long anyway. 2x minus y equals to 4. Okay, I see the y is negative. Let's move y over and make it positive because we want in the form y equals to x plus c. There's no negative here. It should be positive y. Add y on both sides, so I get 2x equals to y plus 4. And I can subtract 4 on both sides. Y equals to 2x minus 4. Gradient is 2, so it is line D. So A and D are parallel. Next one, circle the equation of the x-axis. Okay, so let's have a think about this now. Let's draw out the coordinate axis. Okay. Well, let's think about, let's draw in black then. That's the equation of the x-axis. So we can just imagine this as a straight line. What's the equation of this black straight line? Well, let's think about it here. Could it be this one? No, definitely not. Why not? Because you can show that the gradient of this line can be written y equals 2 minus x. The gradient of this line is minus 1. Okay, so that's going to look something like this. Okay, it's going to go from here to here. So definitely not that one. By the same logic, it's definitely not this one either, because this one can be written in the form y equals to x, and then y equals to x looks like that. It's got a positive gradient. It's going to go from bottom left to top right. Okay, so we're left with 2 now. X equal to 0, y equal to 0. Well, let's think about every point on this line. What's the coordinate of every point on this line? Have a pause and think about it. Pick any point along the x-axis, no matter how far you go along, and tell me what is the y coordinate along the line. The y coordinate is 0. So y equals to 0 is the answer for this. It's a little bit counterintuitive. X equal to 0 is the equation of the y-axis, because every point along this line, this red line, has an x coordinate of 0. Okay, that's the way I like to explain that. So just think about every point along the line and what its coordinate is. Conversely, similarly, you can have the equation of y equals to 3. That would look like this, because every point on this line has a y coordinate of 3. And you can have the line of x equals to minus 5. And again, for the same reason, the x coordinate of every point along this line is minus 5. So let's have a look at this one here. Find the equation of the line that passes through C and is perpendicular to AB. So pause the video and have a think about it. Okay. Passes through C and perpendicular to AB. Let's draw in the line. Okay. So it has to pass through C. And it has to be perpendicular to AB. So it's going to look something like this. Okay. And this has to be a right angle here because it's perpendicular to line AB. Okay, let's think about perpendicular lines. The gradient of them are the negative reciprocal of one another. So let's write out the coordinates of A and B. The coordinates of A is minus 2, 0. The way you can think about that is the y coordinate is 0 units upwards. Okay, so it's 0. The coordinates of B is 4, 0. And again, the way you can think about that is that the point B is 0 units to the left or to the right. Okay, it's right smack bang in the middle, so the x coordinate is 0. Let's find the gradient between these 2 points. M equals to y2 minus y1, so 0. Oh, no, I made a mistake. Definitely made a mistake. This is wrong. No, this is wrong. This is 0, 4. Okay, the reason is because this is 0 units to the left or to the right. So the x coordinate is 0. Okay, I think I said the correct explanation. Okay, so it's not too bad. Only one mistake as far as I'm aware. So now y2 minus y1, so it's 4 minus 0, which is 4, divided by 0 minus minus 2. And 0 minus minus 2 is positive 2, so it's 4 over 2, which is equal to 2. Okay, so this line has a gradient equal to 2. This line is perpendicular to it, so we know the gradient of this line is the negative reciprocal of 2. Okay, so what's 2 as a fraction? It's 2 over 1. Flip the fraction, becomes a half, put a negative in front of it, minus half. Minus a half is the gradient of this line. Easiest way to do it. Okay, so we know the gradient of this line is minus a half. We know a point that it goes through. So let's write out the information we know. Y equals to minus a half x plus c. Okay, we know the gradient is minus a half, and we know it has to be in the form y equals mx plus c. Okay, well, we have a point that it goes through. We know the x coordinate, we know the y coordinate, and there's a nice little convenient place for x and y. We can substitute them in. Y is minus 1 equals to minus a half lots of x, which is 5. plus c. Okay? Minus 1 equals to minus 5 over 2. Oopsies. Minus 5 over 2 plus c. Okay? What I can do now is, well, I know that 5, if you're wondering how this happened, minus a half times by 5. Well, what's 5 as a fraction? 5 is 5 over 1. How do you times two fractions? You times the top, you times the bottom. What I can do now is I can add 5 over 2 on both sides. So I get c equals to minus 1 plus 5 over 2. Find a common denominator. So it should be minus 2 over 2. Let me just check that. So it's minus 1 plus 5 over 2 over 1, 2, 5. Yeah, it's 2 over 2. Yeah, that's fine. So it's minus 2 over 2 plus 5 over 2. So c should turn out to be minus 2 plus 5 is 3 over 2. So c should turn out to be 3 over 2. So I know the equation of the line is y equals minus a half x, because I know the gradient is minus a half, plus 3 over 2. And I think that is the last question. Yep, that's the last question. So we're done. Thank you very much for watching, and I hope it helped. Please remember to like, comment, share, subscribe, and remember check down in the link. Check the links in the description below for all the worksheets that I use. I'll link them below so you can have a go yourself. Thank you very much.